So this is a demonstration of the Penn Productions new RAIC control system using motion capture data. Motion capture data is actually applied through the TRC file format mainly, but can be pulled off of other characters, other objects in several different ways. With the TRC is track row column. This is the raw marker data. This is the just the markers that have been captured in the motion capture suite, then cleaned up for occlusions and any sort of noise. So first off, what we have is a settings, and the settings allows you to be able to load onto the character a settings file that describes to the system how the markers are to be used for each of the controls. Different setting files can be saved for each mocap session, different characters, and it's just a text file that describes all of the settings used. Next step is simply importing the TRC data, and what we have is all the marker data being created. You can actually see it at the bottom here now. It's actually created a set of markers and parented them up to a helper object in the center of the scene. And that marker data right now is receiving all of its key data, and that key data will describe where that marker should be in the scene in a global position. Once it's loaded, you can see the markers now in the center here, and this is a raw motion capture file. It starts and ramps up over a number of frames, and you can see the character now, character's markers now flying out. They get into position, and the animation starting around frame 400 some odd frames in. So the other is just the ramp up that often happens. That can be cut out in the marker data cleanup session. Now you can see the markers appearing though as they're walking and chasing across the scene. And again, once again, this is just the raw data. Each marker is keyed in position as it was when it was originally captured. Back with the character, all we have to do is say mocap and apply the auto. And then when we scrub, what you'll see now is that the character actually is chasing those markers and following those markers in the scene. You can see that it's doing its best to keep up to them. It's pretty much real time as you scrub in the max viewport, and you can see how the character is trying to keep up with it. Now, to make sure that everything lines up, it's best to use the ROM file, which is the initial setup file, so the character in the T-pose. And you can basically set up the character to make sure that it aligns to all of the markers correctly, and then save the settings for that mocap session. It's easily done by just grabbing any control object and aligning it. The toe looked like it was rolled up too high here, so I'll roll it back down again, and then just tell it to apply the offsets from the markers. So at any point in time, you can go through and grab and say, well, I need to readjust how this is actually functioning with these objects, all the marker data, and I'm not getting the kind of results. So I want to change up how it's oriented to the marker data for the duration of the capture. The capture can be done in multiple different ways. One, here we have an FK arm. We can also get the IK arm solution as well. So here's the IK arm, here's the FK arm. You can see in this case we're going with joint angle solution for the FK arm. Joint angles means that it's trying to attain the angles that the marker data attained. Now there's been some offsets applied here, so we can see that it's a little bit different, and we can adjust that and then save it off again. So here's the clavicle area. You can see these markers. This is the shoulder, and this is the front shoulder markers. And these are tricep markers, and down to the elbow. And you can see that the character that's being, the mocap's being applied to doesn't have necessarily human form. It's got a very short upper arm, very long lower arms, and the marker data obviously came off a human, so they're quite even. But you can see that from the shoulder markers to the elbow down to the wrist, which is down here, this is the outer wrist and inner wrist, you can see that the joint angle is being respected. Of course, it's not attaining the marker. Now we can where the wrist was. We can actually have it try and set that up for the FK as well. We can actually have it try and target the actual location of where it was and try and attain it as best as possible. I've just done a little adjustment on the shoulder here to try and get the angle of the arm this way a bit better. I'll just say apply offsets so that now it actually tracks that the way I've just asked it to. The other solution, of course, is the FK or the IK solution. Sorry, the IK solution is set up to bias the actual position of where the wrist was. So you can see that the wrist is trying to attain the position where the wrist actually was in the actual motion capture file. This has the advantage that your character needs to lock its wrist down at any point or hand down to anything in the mocap. You can actually use an IK solution. Now the advantage of going from markers instead of going from rotational data as in a BVH or HTR file, what you have is the ability to be able to change it up and say, well, I want it to work this way or another way. Whereas once it's been baked off to a rotational data, you're stuck with one solution for both your IK and FK. Where here I have the ability to be able to pick and choose which is going to work better for any given mocap session and cleanup session for the motion capture. So I just adjusted the wrist a little bit here, get it a bit better position again. I'm going to apply some offsets, and you'll see again it's now chasing that position and trying to attain that position as best as possible. Same thing with the elbow. It's doing the same thing, and you can see it's even staying offset from where the elbow is. You can offset it as much as you want, and it'll again maintain those offsets where you put it, so it'll actually stay out from the elbow and not jump to the elbow. So once you've got your data all worked out and set up how you like your IK and FK to be working, and it's following the character appropriately, all we have to do then is go about baking the animation into it. Now let's just take a small section here so it doesn't take too long. We'll go from frame probably 1200, so we'll say 1200 to frame, maybe we'll go to 1500. And you can also set up a frame step. That frame step is how often it'll set a keyframe. This can really help you actually. A lot of motions you do, there isn't necessarily jitter because the markers have been cleaned up, but it's not as smooth as you like, and you have to take a bunch of time trying to clean that up and getting the solution out of it you like in the cleanup process. Well, you could actually not set a key every frame in this case and set a key every 10th as it's currently set at. Let's do a key every 5 and see what we get. The rate of capture right now is at 60 frames a second, so it's actually moving very slowly compared to how it should be. We're going to convert that rate down to 30. And then all we have to do is say bake mocap keys. And what you'll see now is it goes through the process of baking those mocap keys. Now you'll notice that the data has been baked down here and not where we asked for it, and that's because the rate was a different rate. So it's been baked at the current rate at the correct frame times. So now you'll see the character going through its motions here and following along. Now to see it actually following the markers once it's baked, I'll just I can delete the markers and re-import them if I like. But you'd have to bake it at the real time, so 60 to 60, and you'd be able to see it following the markers once it's baked. But now here's your animation baked, and it's been baked onto an animation layer, and that animation layer can then be adjusted from there. So right now it's been set up into a mocap layer, and that mocap layer allows you to be able to delete the keys or work with the keys in the motion capture layer, or move on to an animation layer. And so we'll just say this controller active only. You can see that when I pick mocap, here's the keys for the mocap on the foot, and there's the animation layer. So we can go about animating this however we like now to offset it, or go about cleaning up the motion capture keys and working with those mocap keys on the character. Like I said, this isn't a system whereby it's a biped. It can be any object. I could track a basketball to motion capture data. If you could get a chicken into a mocap suit, I could also mocap, transfer the animation over to a chicken rig. It could be a quadruped, could be anything at all, because these RAIC controllers are autonomous controllers. They stand alone in the scene, but they understand their environment, what's around them, and what part of the rig they belong to. This allows them to be exceptionally flexible, set up just about anything with them at this point. I hope you enjoyed that demonstration.